Good evening, CoffeeJug. Today we're happy to see Venkat with such an interesting topic to speak. But before we proceed, don't forget to support our Ukrainian armed forces. You can donate any money you have to any charity organization you know. It would be highly appreciated if you can do this during the topic as well. Uh, Also, we want to say thank you for all participants for being a such active person of our community. We highly appreciated this as well. And also, we want to say thank you our organizers team, Igor, Alesa, and Oleg, who do a lot behind the scene. And join us in our social medias and wish you a good talk. See you later.
All right. Well, greetings. I hope you're able to hear me, and let's get going. Greetings, everyone. Thank you so much for joining. First of all, my love and affection to everyone over there and elsewhere. So be safe and let's stay together during especially these times. I'm going to talk about object-oriented programming versus data-oriented programming. Best time to ask a question or make a comment is anytime you have a question or a comment. Don't wait till the end. Anytime you have a question is a great time to bring this up. And I'll be delighted to discuss and dive more into based on the question you're asking. Well, we've been using OOP for a long time, and I want to talk about that and a relatively new feature in Java that could be a way to consider maybe an alternative design. And when do we choose it? We'll talk about some of those things along the way. Well, first of all, let's talk about object-oriented programming. Well, we all have been using OOP. I started programming way back in time when OOP was just in the beginning stages. I'm talking about 35, 40 years ago. It was just being adopted. It was not mainstream just yet. Of course, on the other side now, it's not only mainstream, maybe we could even argue that sometimes it's being overused than it's supposed to be. Well, we can talk about the four pillars of object-oriented programming. We can say the first pillar is abstraction. And abstraction is nothing specific to OOP alone, even though OOP builds on abstraction. Abstraction is where we do modeling. We represent an idea that we have. We often have abstractions for dealing with things. For example, you might have a little flag that says when something is ready and somebody can pick it up. That's an abstraction, a representation of certain concept, if you will. And we have done abstraction ever since humans have been in existence. Way back in time, even people like Plato have talked about abstraction quite a bit in terms of how we humans. So abstraction is useful for us to deal with complexity. That's how we say sane. We stay sane and are able to comprehend complex ideas in our mind. Well, the second pillar in object-oriented programming is encapsulation. Once again, I would argue encapsulation is nothing specific to OOP alone, but OOP heavily depends on encapsulation. Encapsulation, I'd like to say, is a separation of what you can do from how you can do it. So it hides the details of the implementation while providing you access to what it can provide. Encapsulation is again not necessarily restricted to objects. We can have function level encapsulation. A local variable defined within a function is encapsulated. A lot of languages allow file level encapsulation. So whatever you define within a file can stay within that file. That's another way of encapsulation. And of course, you can encapsulate things within an object and subsystem and so on. Well, the third one is inheritance. And I would say inheritance is probably the weakest link when it comes to object-oriented programming. If you're predominantly programmed in languages like Java and C Sharp and C++, you might say, gosh, how can you do anything useful and write extensible code without inheritance? But as it turns out, a lot of languages allow for polymorphism without needing inheritance. So inheritance is a weakest link. It also increases type coupling between classes in general. But the last one is polymorphism. And to me, this one is the one that shines the most because polymorphism gives us the ability to write extensible code. So, what does polymorphism say? It says go ahead and call a method at compile time, the type of that reference may be something different from the type of the reference at runtime. But the code that's going to get called for that function at runtime is based on the runtime type of the reference and not the compile time type of that reference. So this gives us the ability to write dynamic code where you can have the code, invoke methods on even classes that may not exist during compilation time. Those classes may come in later, but the code is able to branch off and call those methods. So these are the four central pillars of object-oriented programming that we have been using for a long time. But the question I want to ask is, when should we really use object-oriented programming? I would recommend doing OOP when we really want extensibility in our code. So to me, that's one of the reasons why I often gravitate towards object-oriented programming. The other reason you could say is that you want to take a group of data and you want to bundle them together into an object. Well, that is creating a data structure. You could call it as a struct, if you will. And we've had struct in even languages like C. So that doesn't make it object oriented. You can call it object based, but for object oriented, what is the difference between object based and object oriented? In object based, you can have structures and classes. In object oriented, we got that extensibility that comes in nicely. So this is why I would say this polymorphism is a very important notion when it comes to object-oriented programming, and we often tend to rely upon it quite a bit. So having said that, the essence of OOP to me is that really leveraging that polymorphism and getting that extensibility, if you will. Let's think about where this can be really helpful. So imagine for a minute, and I'm going to use an extremely overly simplified example in here. So here is an order processor, as you can see, and this order processor is simply providing a method called process order. Well, maybe the business told us we want to process order using a credit card. So we have written the code to receive a credit card somehow from a user and pass it to process order. So if we look at the process order function, it does some work before it charges the credit card. Obviously, if there are errors or status or information received from the charge, it needs to make use of it. I'm not going into those details. And then it does some more work afterwards as well. Well, this is great so far. And that's the code we have right now. So not a big deal, right? It says charging credit card for $1,000. However, in the future, let's say, so in the future, if the business, let's say, wants us to receive payment via other methods. So essentially, the business says, yeah, we've been accepting credit card, but we got other alternatives. We want to receive payment through one of those ways. How do we do it? Well, let's identify the design flaws in this code right now. So as is, we could say the order processor, you could say, is tightly, you could say, coupled to a credit card, if you will, class. So this is not a great idea, isn't it? So when you go to the order processor, you can see the order processor is depending on the credit card right in there. So that is tight coupling. So the order processor is tightly coupled to the credit card class. This violates both, you could say, well, actually, it violates the open closed principle. So, what does the open closed principle say? Well, Bertrand Meyer coined this term open closed principle, and he says, essentially, you could say a software module, this could be a function, class, subsystem, components, right? And so on. You could say whatever it is, right? In your definition of what a module is, not a Java module, obviously, in this case. A software module should be, he says, open for, you could say, open for extension, but closed for modification. Now you're like, gosh, that sounds like magic. How could we do it? Well, in other words, the idea behind this is it is much easier, if you will, to add a small new piece of code, than changing existing code, right? At least that is, right, the highly regarded opinion. So is that correct? Well, we'll find out. So that's basically the idea. So it's really the case that the software module is open for extension, but closed from modification. So we don't want to modify anything, but we want to be able to add a little bit of code and walk away. So the question is here, how can we make the code, make that code extensible? So that is the question we want to really ask. And the answer oftentimes is we can apply the dependency inversion principle. So here's the funny part. Almost any time we violate open close principle, we can fix by using dependency inversion principle. So this is why these two principles work in tandem with each other oftentimes. So you can say, gosh, we violated open close principle. We can fix it by using dependency inversion principle. What does DIP say? DIP says that a concrete class should not depend on another concrete class, you could say. Instead, both should depend on an abstraction or interface, basically. So essentially this says, hey, rather than the order processor depending on the concrete class credit card processor, they both should depend on an interface. So we can apply a DIP. We have done this extensively, right? If you have ever written a Spring code, you probably have used a dependency inversion, or we inject dependency into classes. That's how we can decouple, right? So this allows, right? So this allows for us to decouple a class from its dependency that you really have. So essentially, what I'm going to do here is to go back to, if you will, this particular class where we are calling this. And rather than doing this, we can go to the credit card, first of all, and we can say implements in this case. So implements, we can call it as payment method. So credit card is a payment method. Well, what in the world is a payment method? Well, we can create an interface called the payment method. This contains a method called pay, which takes an amount in cents, if you will. So we have a pay method that we added to the payment method. So we can come back here now and implement the pay method, and I'll just turn around and call the charge and pass the amount in cents for now. So we have a payment method, a pay method, which is part of the payment method. How does that really help us? Well, the benefit of this is we can now go to the order processor. We can decouple it from this to using a payment method. And as a result, this becomes a payment method, and the parameter becomes a payment method as well. And we simply say a payment method dot, we could say a pay, and we are receiving the payment for that method. What's the benefit? The benefit of this, of course, is we can go back to this code and tomorrow, so notice the code is still working, but in the future, we could have said order processor.process order, and rather than saying new credit card, we could have said new, for example, in this case, let's say a bank transfer, and whatever that requires, details for the bank transfer, we can provide it. And the bank transfer itself is a class, and that class is going to be within the payments. And guess what? It readily implements the payment method, as you can see, and is going to do whatever work it needs to do within this. So what is the consequence of this? The benefit of this is, as you can see in here, to use the bank transfer, we did not have to modify the order processor. So this is where it really comes down to the open close principle. And to honor the open close principle, we ended up using dependency inversion principle. We could stop here and say, yay, OOP rocks. This is exactly how we should be developing our applications. End of story. Let's go home. Thank you for coming for the talk, isn't it? Well, that's actually not untrue. This is extremely powerful. However, one of the things we want to keep in mind is almost anything we have in both life and programming, there is a point of diminishing return. So when you're not using it, you're not getting any benefit. You start doing it, you are getting benefit. It's like exercising, right? If you don't exercise, you don't get benefit. You start exercising, you got the benefit. But there is a time when you could over-exercise. And what happens if you over-exercise? You could cause injury to yourself. It's a waste of time as well. And there are other consequences, right? So there is always like this curve. So you're not benefiting because you're not using it. You got benefits because you're using it. That point where you have the tipping point where more you do, you don't get as much benefit. Pardon me. It could actually be worse as well. So the question you want to ask is, for OOP, what is that point in that curve? So you are beginning to use OOP, you're getting the benefit, so you're up here and it begins to curve and flatten and begins to tilt. What is that point? If we can find that point and stop and not overuse it, we're going to get the benefit of OOP. But the question is, wait a minute, if you stopped there, we still have problem to solve. How in the world are we going to solve the problem if we're not going to use OOP? Well, let's look at the tipping point before we go any further with this. So let's shift our focus just a little bit to something other than what we have been seeing. Imagine for a minute, in the example we saw, the client code is ours. We also are keeping track of the order processor. That's our code. The credit card is our code. The payment method is our code. Everything there is our code. When everything is your code, you have full control over how you want to modify that code and how you want to maintain that code. Oh, before we go further, I'm a big fan of interaction. So I'm going to ask you a question. Don't worry about being right. Don't worry about being wrong. Can somebody guess Don't Google for it. Don't look at AI engines for this. I just want your pure impulsive response. Throw the number at me. So, do you know what year object oriented programming became mainstream, became popular, that you could not stop people from talking about it? So, what year, not what year it was created, but what year did it become mainstream when everybody started talking about it? I know some of you probably were not born at the time. Maybe some of you were, using it extensively by the time. But what year did OOP become mainstream? So what are the years that you can think of, right? Oh, clicking over here to see the comments. I see one comment here. The year is 210, 2010 rather. No, 210 would be really weird, right? Yeah, no, it feels like it's been around for a long time. 2010, 24 is another response. As it turns out, it was early 1990. So 92, 93 time frame. Yeah, that's right. It's 1990, as Andre says. It's 1990 is when it really became popular. 1992, 93 time frame. Here's another question. What year was object-oriented programming introduced? When did they create it? We could say, wow, gosh, you said it became popular in 1990, so it should be 1989, right? Well, let's rethink about it. What year did OOP get introduced? Does anyone know the answer for that? Again, don't look up. Don't look up on the net. Just your gut feeling, your guess. What year was OOP introduced? So let's see if we can see any responses for that. 1970, 1965, not bad at all. It was right in between those two, 1967. So the object-oriented programming concept was introduced in 1967 by Dahl and Nygaard, two Norwegians who actually introduced this. So this is a concept out of Norway back in 1967. So can you imagine that between 1967 and 1992, approximately 23 to 25 years. What a long time for it to become mainstream, isn't it? Thank you for that response. I really appreciate it. So let's look at one other example here. So here is a sample trade. Now, imagine for a minute that we have some third-party classes and interfaces. This is not part of our code. We don't have the ability to modify this code. So this is a third-party code, and this third party, it doesn't belong to our control as to what they can change. This third-party code could be used by many different teams. It could be a separate third-party library. So it contains a trade as an interface. It contains a buy class, which implements trade. It also contains a sell class, which implements trade as well. So we got these three things, right? We got the trade, the buy, and the sell. They don't have a whole lot right now. They got some data, and they got a perform operation. So the perform operation, let's hypothetically think about it, performs the trade on a third-party system. That's what we want to do, is to call this perform to perform the trade. In this example, trivially, I'm just outputting performing buy or performing sell. But imagine this is actually performing the transaction on a remote system. That's what I want you to think about. So that's our third-party code. Now we are using this third-party code in our application. So what are we doing within our application? So we have a process trade, which is using a buy or a sell to process a trade. Well, this one is simply calling a trade.perform. That's all it's doing, right? It's just calling this trade.perform. Now our business says, well, good, you're performing the trade given the buy or a sell, but we want you to do some auditing when you perform the trade. So before you perform the trade, we want you to do some auditing. If the quantity is greater than 5,000 for a buy, or the quantity is greater than 10,000 for a sell, we want you to do some auditing. Now, how do I implement this code to perform the auditing for the buy or the sell? Well, I'm going to simply call an audit method right before we call perform. Now, one of the things I have done as I was playing with this example is just a little bit more ambitious. Instead of calling the audit method right here, I brought in aspect J and I implemented an aspect oriented programming to do a point cut, and automatically before the perform, it would call the audit method without me calling the audit function. That was a really interesting example I created. And when I finished it, what I realized was that code had more complexity than it was worth to illustrate the concepts. So I threw out that example of using AOP and fell back to something simpler. But the idea you want to think about here is that in your code, anywhere you call perform to perform a trade, you might want to do audit. And like I said, an AOP, an aspect of the programming, is an ideal candidate for that, but that's just a more complex code. It only hides the details from us to our delays where we want to get to in our discussion. So I threw that away and simply calling this method. So when I call the audit method, the question is, what are we going to do in the audit method? Well, as you can see here, we are receiving some trade that we want to work with, right? So that's what you have in here. So to work with this trade, what are we going to do? Well, the answer to that question is we need to take the type of the trade that we are working with, and we want to really say for this type of trade, we want to say, hey, if it is a buy and if the quantity is greater than certain value, do some auditing. If it's a sell and the quantity is greater than some value, do that auditing. So how are we going to actually accomplish that? Well, all I'm going to do here is to take the trade that we have received and I'm going to ask it to perform audit for the type of trade. But I'm a big fan of object-oriented programming. I believe in using polymorphism, and we're programming in Java here. So in order to use polymorphism, we need to bring a hierarchy of classes and interfaces and such. So what are we going to do? I'm going to say trade audit, and we'll call it as trade audit is equal to, and we'll call it as a create trade audit, and we'll pass the trade over to it. Once we get the trade audit, we'll call audit on it and pass the trade to it. Now there's a name for this pattern. I know a lot of us are big fans of design patterns, right? So what's the name of this pattern? I like to call this pattern as kick the can down the street pattern. Well, because it didn't solve the problem. It simply took the problem and said, here you go, and passed it on to the next function. So this is like a boring day. You just kick the can down the street, and it didn't go away. It is just there a few meters away, and you got to go there and kick it again, right? So we just move the call from one function to another. But we'll entertain that, see where it takes us. So what we're going to do now is we need this trade audit. So let's go ahead and create a interface called a trade audit. We're going to put that interface, which is called a trade audit, and we're going to put that into the code. Well, where are we going to put that in here? Well, let's actually create that in here into an, let's call it as, we got payments and bank transfer We don't want to put that in there. Let's keep it in the client for now to see how we are going to provide it within here. So let's go ahead and create the trade audit. And the trade audit is an interface, and we're going to simply create that interface like so. And what is the method that trade audit has? It's got a method called audit, as you can see in there, and that's basically our interface right there. Okay, so we have this interface, but what does the trade audit function actually do is the question. Well, the create trade audit function, let's go ahead and create it. So here we're going to say the create trade audit is going to return a trade audit. It takes a trade, but how do we create a trade audit based on the type of trade we're going to be using? What kind of pattern can be useful to create a trade audit appropriate for a trade that's given? So if it's a sell, I want to create a sell trade audit. If it's a buy, I want to create a buy trade audit. So how would we go about creating a different audit for different classes? What pattern comes to your mind? We all enjoy patterns, right? This is not a kick the can down the street pattern, but it's a more of a legitimate pattern we probably have used in the past. Does it come to mind for anyone what that pattern might be? No, I don't see any responses yet. Let's see if we can think of a pattern that we would normally use given a particular type of an object. We want to create a similar type of an object, but for a different purpose. So we are going to, a few different patterns may come in. So no, I don't see any responses yet, which surprises me. We could use a factory, some kind of a factory, right? So we could use a factory to create it. Well, a strategy is a different a concept, though. A strategy often is useful for decoupling algorithms you want to use, but this is more of a creational pattern. So we could use an abstract factory, if you will. That's one option. We could use a factory method. That's another option. We could use a prototype pattern. So these are all different options. So typically a factory would come in. But in Java, we have a very easy way to do that, right? So what are we going to do? We can say a class, right? A trade class is equal to, or trade class name is equal to. We could say this is going to be a client dot and a %s, and we could say format it, and this becomes a trade dot get class dot get simple name, and that gives us the full name for this class. So we have a client, that is where, pardon me, we created this trade audit. Let's go back over there. That's under the client, as you can see. So we said client dot and that. You could put that in a different package if you really wanted to. Well, we got the class name. That's pretty innocent so far. What are we going to do next? Well, we can then say a var. We could say trade audit is equal to, and this becomes a trade audit. So we can say this is a trade audit, and we can say trade class. Well, first of all, pardon me, this is a trade class. I'm taking, each step at a time. So the trade class is equal to, and we could say a class dot for name, a trade class name that we want to use. And the minute we do this, Java is telling us, ooh, you got to handle this exception, don't you? Well, okay, I'm going to just pop that exception in here and ask it to handle that one. So let's go ahead and say that I want to surround that with a try and catch block. Okay, what's the next thing we're going to do? The next step here is to say var will say a trade audit. And pardon me, here I made a mistake. This is a trade audit class, right? Not trade audit. So trade audit is equal to, and we're going to say in this case, a instance of this class, right? So trade audit class dot, and we can ask it to get the declared constructor, And on the declared constructor, we can call the new instance on it. I don't have any constructor arguments to provide to it. And so now I can simply cast that over to a trade audit as an object, and we can return that back to the caller. Well, that only prompts us to handle more exceptions. So we'll ask it to surround that with more try and catch block right there. So surround with try and catch. And how does that feel? Scary, isn't it? So that full glory of throwing more exceptions on it. And, I could simply say, this is scare the heck out of the programmer, right? Pattern. So if you're into design patterns, that scare the heck out of the programmer pattern, right? So that basically is the code we created to, boom, create the type of audit. Well, great. Now what are we going to do? Now that we have the audit, we can go perform the operation. But what if the audit doesn't really exist? What are we going to do is the question. Well, in order to support that, you'll have to go back here and you would have to say, hey, we're calling this audit, but within this audit, if the class doesn't come through, we'll do a catch runtime exception, and we can say, throw, or let's just simply say in this case, throw, well, actually, let's just output for our purpose. We can say, invalid, valid trade did not find the appropriate audit, for the given trade. How about this? We'll simply say did not find the appropriate, audit for a given trade. So we're going to blow it up and say, sorry, we couldn't work this. So we haven't finished implementing this, but let's go run the code and see what it says. It did not find the appropriate audit for the given trade, and we see those errors. So how do we fix it right now? Well, that's kind of easy, right? So we can go back to the audit rules and say, aha, I really need two classes in here. One is going to be a by audit, right? We need that one. So we can say by audit. So we could simply say new by audit. Just for now, we can use that to create this class. So we can implement that class right there. And what would you do in that function? Well, in the audit function, you could say, aha, this is a trade we are receiving. But here's the problem. If you change this to a by, notice that you get a compilation error. Why are you getting a compilation error? Not because we didn't reference it, right? It's because the base method is taking trade. You cannot use a by in here. So what do you have to do to make use a trade in here? Well, to use a trade, unfortunately, you would say if the by trade is an instance of by, and you can say by, well, then that's great. Otherwise, what are you going to do? Else, you could say throw new runtime exception, invalid trade given to this audit. Well, you cannot give me something other than by to audit if it's a by audit, right? That's what you're saying. So what are we going to do here? So this becomes, in this case, if the by dot quantity is greater than, we can say 1,000, then according to the problem, auditing, you could say auditing the by, so auditing the by which is over 1,000 in quantity. So you can provide that like so. So when you run this code this time, what you're going to notice, oh, pardon me, I was using convenience and I forgot to remove this, right? We don't want that, obviously. So let's get rid of that. That was just to kind of make the IDE do some extra work for us to create that interface. So let's go back and run this code right now. And notice it says for the by, did not find a proof. That was bad. So let's see what just happened here. Maybe I made a mistake in naming this properly. So the point is That's a bit error prone as well, isn't it? So let's go ahead and fix it. So what do we receive? We got a trade, which is a buy. So we come down here and ask for the trade. Aha. So we need to take the name and put the word audit in there after that, isn't it? That's a little detail that I forgot to implement. So let's run the code now and make sure it's working. So obviously, I have no clue what I'm doing here, right? So what's going on? So let's go back and look at this. The code we just wrote, the buy audit, is in client, and the name is buy audit. Well, what's the simple name that we receive in here? So this simple name, I'm going to just output that for our purpose right here. So this is going to be the name we are receiving, right? So we'll say a trade class name. That's what I really want. This is a trade audit class name. That's the name we really want to provide here, but you get the point, right? So let's go ahead and refactor this to, this is going to be renamed to trade audit, right? So trade will say audit class name. There we go. And we take the trade audit class name and we are trying to create the object for that one. So if I were to execute this, let's see what the name is. Client.buyAudit, which is the name here, I suppose, for our audit that we created. So buy audit, right? So right there is buy audit, client.buyAudit. So that name is correct, right? So that's what we want to create in here. So that's our buy audit. And then we are asking our buy audit to be created for this class. So what's that going to be? Trade audit.class is what we are creating. So this is going to be the trade audit, class, not the class name that we are interested in creating, right? So essentially, this is where I'm going to see the type it is creating. That's a by audit class. So that's fine as well. Do I have a constructor I can call is the next question we want to ask in here. So if we go back to this, we got the audit. Now we are saying, get me the trade audit class, get declared constructor for it, and create a new instance for that particular class. That's what we are asking it to create. Let's find out what the error was, right? That would be actually useful to find out, isn't it? So we'll get the message right here and print it so we can know what the actual issue was. What a concept, right? That would be useful to know what the issue was. So let's go back and run the code, see what the error message says. And it says, client cannot invoke the audit because trade audit is null, it says. Aha. So for some reason that I don't understand, it is, does anyone find the problem here? So what's happening here is that I'm getting the client by audit. We're asking it to create an object right there using the constructor for that object. So basically we said get constructor, and declared constructor versus constructor, it should really have a public constructor to use it. Let me try that and see if that actually works rather than the get declared constructor. But as you can see, this involves using reflection or other means to create the object, and that can take a little bit of effort. But I'm going to kind of give it up at that point to see where this is going. For some reason, it doesn't want to create the object that I don't know the reason for it. This is supposed to have created the object of that class, which is the by audit class. And clearly, others have no clue looking at this as well. I just lost faith in pair programming along the way because I had no help from the group here. But you kind of understand the point about where I'm going with this particular solution, right? So we are asking it to create the object for the by audit. And the by audit that we have in here is really the class we are implementing and creating the object of that class. And like I said, the constructor should be there. It should have created the object. I'm going to try just one more thing, and then I'm going to give up if it doesn't work and move on. It's just to call the deprecated method because that's a bit easier to call here as well. Let's see if that were to really work as well. So let's go back and try that one and see if it were to come through. I know that's a deprecated method. We shouldn't call it, but at least it should be using the proper constructor that's available at this point. Let's see if that actually works. So let's go ahead and try that one more time and then see if that were to come through. All right, so let's go ahead and fire this up one more time. And in this case, no, I'm going to just leave it at that. Okay, you get the point. So essentially what we're going to do here is we're going to create this object, invoke the method on it, and then of course that auditing is going to kick in and it's going to perform the audit, which is the audit rules, sorry, the by audit, which is the trade audit. Well, here's the question. If we implement this code, what are the benefits and what are the disadvantages of this approach as well? Well, let's jot that down to understand the pros and cons of it. So, but before we go that route, what are the other thing we're going to do eventually in this example? Well, in this particular example, as you can see, we got the client by audit. We're creating the object of the by audit, and that's a trade audit, and we're returning that trade audit to the caller from here, right? That's what we are doing. Similarly, we'll have to write one more class, isn't it? What's the class we'll be writing? Well, we'll be writing the class, which is trade audit, is going to be new sell trade audit or sell audit. Well, how does the sell audit look like? Well, the sell audit is going to be a class which implements trade audit. But as you would imagine, how would we implement the sell audit in this particular case? Well, your guess would be right if you think most of that is going to be a copy and paste, if you will. So I'm going to go back here to the by audit. I'm going to take this code right here, literally copy that code, go into sell audit, and here I'm going to paste it, and I'm going to say that trade, and I'm going to say trade, and this is going to be a trade instance of sell, and we're going to put a sell here as well, and this is going to be a sell quantity is greater than 5,000. Then I'm going to simply use a sell as you would expect. But what did we do in this particular case? This is going to be a sell, right? That's what we are using. But what is the consequence of this? So let's talk about the pros and cons of this approach. So what is good about this and what is, needs improvement, if you will. So the first thing is, what is good? The code is extensible for adding new type of trade, right? How is that? If a new trade is added, we don't have to change anything other than, right? So when a new trade is added, we simply have to add a new type of audit. That's pretty much. So we can celebrate that. So what's the benefit? The code, you could say, in this case, follows the open-closed principle. So, yay, that's awesome. But what are the negatives, though, right? The negatives are, first of all, the code, you could say, violates the dry principle. That's the very first problem, is it violates the dry principle. So how does it violate the dry principle? Remember, we just copied and pasted most of the code from by audit to sell audit, and we just modified the code in there. That's a violation of dry principle. Secondly, there is a lot of code to do this work. That's another problem. Third, if you look at the solution we have right now, if we don't, you can say, right, if we don't add a new type of audit, we get a runtime error and not compile time error. So if a new type of audit is added, a trade is added, if you don't add an audit for it, you will not get a compilation error. At runtime, it will blow up telling you that that doesn't exist, right? Which is really sad and unfortunate. That's another problem that you're going to get from this. So that's another negative that you have as well. But there's more to that particular negative, right? What else is the problem? So the problem is we had to create, in this case, a parallel, you could say, a parallel hierarchy of classes for the trade, you could say, hierarchy. So unfortunately, if you look at the hierarchy of classes you have, so you have the hierarchy of trade, buy and sell, and you have a hierarchy of literally a trade audit, buy audit, and sell audit. So you got to build this parallel hierarchy. So that's a lot of classes, and you could say boiler plated code for that little audit code we had to write. So you could say a low signal to noise ratio as well. So that's another problem, is a low signal to noise ratio that you also have in this particular case, right? So that's another problem. So, and secondly, the code, you could argue, right? The code is hard to explain, hard to reason about. So when you're trying to look through it, you're like, oh my gosh, what is all this, around? And takes actually, more effort to add the audit for a newer trade as well. So the question here that you want to ask is, did we actually gain from OOP, or did we not actually gain from it? So that is really the concern in here. So any questions or comments so far? This is how we can make sure this is different from watching a YouTube video, right? YouTube, you can ask questions to the speaker. We got a different situation here, right? We got interactivity possible here. So what are your questions, thoughts, comments? I like what I'm seeing. I hate what I'm seeing. I've been through this problem before. This has been hell in my application. Oh, never faced this problem. What is on your mind, right? That's the beauty of online versus YouTube. I can record this and post it on YouTube. You can listen to it on YouTube as well. But this is not YouTube, right? This is live. I am talking to you live right now. You got opportunity to express your opinions, express your thoughts, express your experience, express your concerns. What's on your mind? I don't like to speak to myself on a screen. This is one of the reasons I stopped doing online, and I made an exception for this time for this group for reasons that I don't go into right now. But one of the reasons I don't do online much is exactly the situation, because I keep ranting and there's no interaction. So what's on your mind? Is this a problem you've seen before? Is this something interesting? What's on your mind, basically, right? That's the question. So let's make it interactive. Otherwise, what's the point in being here live? I could have recorded this. Anyone? Is anyone connected? That's also a fear I usually have as well. Maybe I lost my connection. Nope. Maybe I'm not connected. Oh, so I'm connected. Aha, Robert nails it, right? It's a trade-off. That's where we are after. It's a trade-off. So the question is, which way are we tilting on our trade-off? That's the question we want to ask. Which way are we tilting on our trade-off? So in the past, I'm talking 40 years ago, when OP was just becoming more popular. We did not have the fancy IDEs. We did not have the refactoring capabilities. We didn't have ability to modify code so easily. So at that time, the cost to find a change and make it was expensive. Today, we have fancy IDEs. So the cost of change. So the question I want you to ask is, what is the cost of change? Is the cost of change the same as it was decades ago? For and the question you want to ask is, what type of change is more expensive than other types of change? So this is the question we really need to ask. And as Robert said, it's a trade-off, right? This is a trade-off. That's all it is. So it's a trade-off. And when you have the trade-off, you're asking the question, are we better off or are we less by doing this? So let's consider an alternative approach just for this purpose. So what we're going to do here is we're going to go back here. Let's take this audit method and let's just comment out that part. And there's more code below and more code in the other two files as well. Keep that in mind. So what we're going to do here is to say return, well, we'll say first of all, return switch, and we can take the trade and we can return some response from this switch. First, we can say default, and the default is invalid trade, can't. So invalid trade, don't know how to audit. So again, this is not going to give us a really, if you will, we'll say message, right, is equal to. And I'm going to print this message out here. So let's print it out. So invalid trade cannot audit. So this is still not going to give you a compilation error, but it's going to give you at least that message. Then you can say case by when by dot quantity, you could say, is greater than 1,000, you could simply say audit large by. If it is not, case by, and this is just a condition. So this is a part of what is called the condition, a guarded case, versus when it's not a quantity, we'll simply say there's nothing to audit, right? Likewise, we can do a cell here as well. And we can say cell, and this is going to be a cell as well. So we can do a cell, and this becomes a cell in here. And that's going to be the cell we want to bring in. And if it is greater than 5,000, we can say audit large cell, and otherwise it's just a cell. We have nothing to audit it. So we can write that code and we can go back and execute it. Well, at least it worked without me struggling, as you can see, with that error I ran into. Well, generally speaking, a lot less code. You can clearly see what's in front of you. Nothing behind the scenes and convoluted. Easy to explain, easy to change. Sure, you have to open that file and make the change in that place, but the cost is minimum compared to the extra file you had to write. Make sure the factory is working properly. Why go through all the trouble after all? So that is the whole point of this. So this is the approach towards data-oriented programming. So what are we saying here? Given the data, make decisions based on the data. So you could say Object-oriented programming relies on polymorphism. Data-oriented programming relies on pattern matching. So essentially, we're using pattern matching rather than polymorphism. So what this really comes down to is polymorphism, you could say, versus pattern matching. If we stop right now, we could still see the benefit. But imagine we go to the third party and say, hey, folks, I got an idea for you. Please, if you will be able to make this a sealed interface. Now, clearly, we cannot change the code, but we can convince the third party, or they get convinced themselves, and they realize they can make it a sealed interface. And they can then say permits, buy and sell are the two things they permit. Then they come down to the buy and change it into a record, which takes a string ticker in here and takes a int quantity as well, which is the buy record, as you can see in here. So that implements the trade, and I don't need this stuff after all. And likewise, they change the cell into a record as well. And where this takes a string ticker and an int quantity as well. And in this case, we implement those three things. But how does it help us? Let's go back here into this code. So the quantity now becomes a method on the buy and the sell. But what's the benefit? The benefit really is that if we don't implement the default, we're okay. And the compiler is going to give us an error. If a new type of trade is added, we'll get a compilation error over here as well. So that's the first thing you're going to see here. The second benefit is, thanks to being records, we can simply say, hey, I really only want the quantity after all. So I'm going to simply say a buy quantity, and I can pull the quantity like so by way of using, in this case, destructuring. Similarly, I can go back here and say, just give me the quantity because that's all I care about. So as a result, we can say this is the quantity is actually greater than 1,000. And we can say in this particular case, the quantity is, so again, this is when, right? So when quantity is greater than that, and we can say when quantity is greater than 5,000, I want to perform that action as well. So we can say that I want to pull in the quantity as an argument in this case. But of course, we know that there's a ticker and a quantity. So we can use an underscore to say, I don't care for that value. And similarly, we can say underscore to say that I don't care for the value. So we are able to use destructuring. These are just bonuses, if you will. The main idea is that we can use pattern matching. But these are just a little bit bonus. Makes the code a bit more concise, but it also gives us a really clear compilation error if a new type of trade is added. So the question really is, we saw the benefits of the two approach. Which one should we choose is the question. The answer to me is, why choose when you can use both? So I'm not going to pitch one against the other. Use OOP when you want extensibility, but at a reasonable cost. As Robert said, trade-off, right? So use the trade-off. If you can achieve extensibility at a reasonable cost, go for it. If that extensibility comes at a higher cost, lack of clarity of the code, too much boilerplated code, too much jungling around, hard to explain, then go for something simpler, which is data-oriented. So can we use OOP all the time? And I would say the tipping point for me is When you're using third-party classes and you want to do different actions based on different data more than classes, that's when I would say time to really ease on OOP, maybe do data-oriented programming a little bit more. On the other hand, if you're using data-oriented programming, and if you find that this part turns into a monster, maybe time to really reconsider, especially if the classes are local rather than being third party. And that's the distinction I would draw from the two, and you can pick and choose which may make sense. Hope that was useful. That's all I have. Thank you. However, won't there come a point when DOP will be insufficient, even more work will be required in the future to refactor it to OP? Might be. And the beauty is this, these are tools, right? So we had one tool before, we got two tools now. So here's the way I would normally phrase this, right? I've been using a hammer, but I have a chisel. And the question is, will there be a time when maybe chisel is not the right thing and maybe we should really go back to use hammer? And we do have the ability to do so, right? That's the whole point, is that you got a choice of these tools. And it's like saying, well, maybe I will use a chisel, but I may have to go back to use hammer. So I would rather continue to use a hammer and not use a chisel, right? So that's the whole idea, is you got a choice. And since you have a choice, you can now wisely decide which option is better in which situation. And that's why I'm saying it's not one or the other. Use both, but for different areas of code. And that way it gives you the flexibility to say, well, now this is more lightweight, so I choose to use this option. Oh, look, this is much better in this case, so I used to this option. So you can justify case by case where OOP makes sense and where maybe data-oriented programming may make sense. Java looks more like JavaScript. Not to me. I wouldn't agree with it, but that's not an argument I would have today. How different would it be, the second solution, without all the 9+ Java features? Would it still be worth the change? But I think that question is a bit irrelevant, because we do have that capability now. So why go through the suffering of saying I cannot use it? If somebody is still using Java 8 and not really moved on, that's a different topic in itself for us to worry about. But the point is this, right? We got modern features available. Those make our lives a lot better. And the argument is, why not make those things better with those options than be stuck with what we had in the past? That's the whole idea behind this as well.
It looks like everyone wanted to spend a couple of minutes to proceed your talk, and then there is a waterfall of question to you. Yeah, guys, if we have no question left, then wish you a good, safely night. Thanks to Venkat, and see you later. Bye.
Thank you.